How's it going, guys? Eugene back with part 3 of the Yeezus test bench series, in which we've been putting together the test bench. You can find that video up here. Getting the benchmarks for 2 Pascal Titan X's, which you can find up here. And finally, in part 3, where I present an overclocking tutorial for your Pascal GPUs. Now, as I mentioned, I'm applying this to my Pascal Titan X GPUs, but you can apply these to any cards in the Pascal range, including 1080s, 1070s, all the way down, and probably any Pascal cards in the future, although that remains to be seen. So at the end of this very short video, you'll be able to apply the techniques we talk about and use them at home to get your very own overclocked GPUs and get all of the performance you can out of your cards. But I think at first, it's important to establish a couple pieces of foundational information that will help us understand what we're doing when we're overclocking. So for that, I've brought a very special guest, Nobel laureate, esteemed computerologist, and my uncle, Dr. Frank Einstein. Dr. Einstein, how do GPUs work?
The GPU is adaptive, which means it draws power and speeds up as necessary to display what the computer is asking it to display. So it starts at a minimal clock speed, and as it ramps up, it speeds up and heats up, and the fans have to blow that heat away.
All right, so with all that in mind, let's go ahead and just do a trial run to see how this process goes before we start applying overclocks. Now, I've opened up EVGA Precision X. This is one of the 2 software solutions that you can use in order to overclock your video card. The other one is MSI Afterburner. It's another great package. I've used it before. Both are pretty stable. EVGA Precision X is just the one that I am more comfortable with and have had better experiences with in the past. But again, MSI Afterburner, you'll notice a lot of the same settings, and this applies equally to that package. So first, let's familiarize ourselves with the interface. Here you have the GPU clock, which is now at idle. Here you have the memory clock. Now, keep in mind, if you're thinking, wow, this is about half of the speed that was advertised for my video card, this is DDR memory, meaning double data rate. So it's performing at twice this speed. Here we have the GPU temperature, which is currently a little high. That has to do with the slightly lower than normal fan speed, which we'll get to in a second. And this is the voltage coming in. Here are a bunch of settings that we will start to mess with once we get into the overclocks. But again, you've got your power target, temp target, the offsets, which we're not applying since this is just the base run, visual indication of the temperature, a visual indication of voltage, which we don't need to pay attention to this yet either, and the fan speed. So since this is already kind of hot, let's go ahead and kick this up. This isn't quite overclocking, but it is kind of manipulating one aspect of the Precision X that will kind of get you familiar with that. So let's go ahead and get this fan speed up to 50% now. Doesn't need to be that high. Let's click apply. It doesn't need to be that high, but I think that we can cool down the GPU a little bit before we start running the benchmark program. Now, if you're running an SLI, the other video card that you're using will be over here. Notice that right now, I've got this little chain. It's linked up. That means that whatever settings I apply to one will also apply to the other. So you don't need to worry about duplicating them. That's true in most respects. We're going to want to monitor what's going on with the hardware in kind of a more robust way than what's offered here. So for that, we go ahead and click on Hardware Monitoring. And this should open up an interface that will probably look pretty similar in your screen, but I've kind of got the different indicators pared down to just the most critical ones, which for me, I like power percentage, GPU clock. Notice that's consistent with what it says up here. Memory clock, again, that matches this. The GPU temperature, GPU voltage, and the power limit, which basically just says, are we hitting our limit or not? 0, we're not. 1, we are. And the blue, in this case, indicates my first GPU. The orange indicates my second GPU. Now, you'll probably have a lot more indicators here if you're just opening the program for the first time. And in order to pare it down as I have, you'll click on OSD settings and go through these various different metrics and click on Show in Monitor, or in my case, don't show this in the monitor, and that'll cause it to appear or not. So finally, the last thing you want to do before starting your benchmark is go ahead and right-click on the desktop and click on NVIDIA Control Panel. And this will let us tweak a couple more settings that are going to be really important. One, click on Setup G-Sync if you have a G-Sync monitor, and disable it. It shouldn't affect anything, particularly if you don't have it on for windowed mode, but as you know, G-Sync limits the FPS that your applications can put out, and that sometimes messes with benchmarking. And after that, you want to go to Manage 3D Settings and go down to Power Management Mode. Now, make sure that this one says Prefer Maximum Performance, and this allows the power management for the GPUs to prioritize performance over power savings, and it'll deliver to the GPUs as much power as they need to run at maximum capacity. Since I already had it, there's no need to apply this setting, so we'll just exit out. All right, so you are ready to start the Heaven benchmark now. I'm using the 4.0 version, and just to go over my settings quickly, I have DirectX 11, quality is at Ultra, tessellation at Extreme, and I have stereo, 3D, and multi-monitor disabled. Anti-aliasing is at 8. And finally, I like to run it not in full screen mode, but rather in windowed mode, because it lets me see the hardware monitors and the Precision X software off to the right side while it's running on the left. Your monitor situation may preclude running it in windowed mode, especially if you're just on a 1080p monitor. But if you can, I recommend doing it this way. So with that done, go ahead and click Run. Wait a minute for it to load up, and let's see what it does. So now that we've got the benchmark running, this is kind of a little bit further into it because I wanted to give the GPUs time to warm up, we can take a look at our statistics here. So the temperatures, it's obviously getting pretty warm now that the GPU has ramped up in speed. The memory clock is right where we have it here, but you'll notice the graphics, which is the GPU clock, is a little higher than both the clock in here, and even the clock in here is higher than what should be the max boost clock as advertised for the Pascal Titan X in this case, or whatever your video card may be. You might be asking yourself, am I already overclocking? Sort of. So this is a function of the GPU Boost 3 technology that NVIDIA is shipping with its Maxwell-era graphics cards. So what GPU Boost 3 does is allow the graphics cards to get a little bit extra performance as long as there is temperature and voltage headroom. It's sort of like applying an automatic overclock that is only kicked into gear when we get up to the higher voltages that are being supplied to the card. So now that we have been through a loop of the Heaven benchmark and have seen that the video cards are probably stable at their core numbers, why don't we go ahead and run a benchmark to get a metric that we can later use to compare the numbers that we achieve with our overclocked video cards and see just how much improvement we got. So to do that, you go up here to benchmark, click it, and it'll just begin right away. Let this run for a little while. It's got a whole cycle that it goes through, and at the end, it should spit out an average FPS. All right, so we've run that first benchmark, we've saved the results, and now we're ready to dip into some overclocking. But before we do that, what's overclocking?
When overclocking, we're using software to tell the GPUs to draw more power and run at a faster maximum clock speed than the manufacturer intended. So because you're drawing more power, there's more speed, it's heating up more, so the fans are getting louder to deal with that extra heat.
Cool. Well, I will crank up the memory clock by a gigahertz, crank up the GPU clock speed by another gigahertz, and just go to town and see how fast we can get these cards to go.
Whoa, not so fast, Eugene. Overclocking has its limits. A GPU can only go so fast. Even if we're in that theoretical limit, we may need to give it so much power that it's going to heat up so much that the fans cannot compensate.
Got it. Okay, well, let's give that a whirl. You'll notice that the GPU temperature is still a little higher than we want it to be, and as Dr. Frank Einstein mentioned, the GPU temperature is something that is really going to be affected by the heat coming off the GPU as we apply more voltage. So let's learn how to deal with that now. first click on the curve button that you'll see in Precision X, and it's going to bring up this window. And here we'll want to click on Enable Automatic Fan Control, and that'll show you the fan curve. And this is basically just a graph showing you, well, when it's at 20 degrees, it should be at 40% fan speed. When it's at 50, let's kick it up to 50% fan speed, etc. We want to apply a more aggressive preset, so you can pick that here, so that the fans kick up more quickly and dissipate some of that heat. But I'm actually comfortable applying a higher fan speed right from the get-go to cool things down right as we start and keep that temperature low, hopefully the whole time. So why don't we start the curve at 50 degrees. Let's move this up here. And as soon as it hits 40, we'll get it up to 60%. Basically just move all these up a little bit. All right, so that should be applied when you click OK. See, it now says custom. So close this and click on auto there, and then click apply. So right away it's moved up to the percentage that we set in the curve. You'll hear your fans getting louder, and you should see your temperature coming down a little bit. Let's click on the other video card just to make sure that it applied there as well. And it looks like it did not. This is one of the things that doesn't carry over even when your video cards are linked. So let's click here, make this look the same. So click on OK here as well, close this, and now we should have the fans moving a lot faster, getting that heat to go down. You'll see here it's 41 already. So now we can begin applying the overclocks. And number one rule, as you heard Dr. Frank Einstein say, is it's all about how much power you put into the card, because that affects how fast it can go, because it needs power in order to go fast. So let's kick both of these up. They are linked. They don't have to be, but I typically keep them linked. You can toggle that here. And we'll take it up to the maximum, 120% power target and 90 degrees temperature target. And we'll make power the priority, which means this is basically telling the software, should I prioritize hitting 120 or should I prioritize keeping it below 90? It is not going to hit 90. If it gets up there, we're having some kind of major issue. So let's kick it to 120 and make sure that this is the number that we hit. Now, for some reason, EVGA has split up the voltage that's applied to the cards between this power target number and this voltage meter over here. And just make sure that that says 100. I know it's red, and red is scary, but we want to make sure that this is getting all the power we actually want to go to it. Again, click apply. This should carry over to the other GPU, and it does. Finally, we can start applying that overclock. And to do that, we will do memory first and then the GPU. So find that maximum memory, then the maximum GPU. For memory, I like to go at increments of plus 100. So just type in plus 100, type in apply, and this process should be very familiar to you by the end of this video. We're going to run the benchmark, keep it going for a few minutes. If we notice any artifacting, meaning weird graphical glitches, if we notice a hard crash, anything like that, we know that we have pushed this card too far, because remember, we know that at the initial GPU and memory speed, it was stable. So here it should be stable as well. So take a look at that memory clock. It's 100 more than it was before. That's because we've applied this 100 megahertz memory offset. And that's reflected here as well. You might even be able to hear my fans getting louder. You'll notice, obviously, the temperature has increased as well. Now, take a look at something else that's happened. This clock speed, even though we haven't overclocked, was never this high when we ran the initial test. Now, that's because we've already given the card more power. So again, this is GPU Boost 3 kicking in. It's saying, I have a little bit extra power available. I'm going to kick up that clock speed a little bit too. All right, so this has been running for a little while, and it seems while the fans are ramping up and the temperature is certainly going up, you can see that on both of the cards, Heaven is stable. So let's go ahead and quit and apply another 100 megahertz to the memory clock. I won't bore you guys to death with this process because you basically just do this until you find the maximum. So let's keep running the test, adding 100 megahertz at a time until we find a point where this thing breaks. At this point, we've been running the memory overclocks all the way up to 500 megahertz, but I think I did notice a little bit of artifacting. I anticipate I might notice a little bit more when I take this to 600, so I wanted to bring you guys back into the loop, see what happens when I get to 600. I also happen to know from my research that this is just about the limit of these cards, so this is where we might experience a crash or some severe artifacting, and I want you guys to see that. So let's go ahead, kick it up to 600, make sure that that's the case for both cards, click on Run, and see what happens. All right, so at this point we've gotten the overclock up to 500 megahertz on the memory successfully, and when we kicked it up to 600, things went south very quickly. There was, artifacting is a mild way of putting it. It caused a system lock, made me do a reset. So I do want you guys to kind of see what that looks like a little bit. So we are kicking it up to 550 to see if that happens again or if 550 is stable for the memory. We can't really see anything weird going on in Heaven, but I am noticing some odd behaviors, let's call them. So if you right-click on my applications, for example, you'll notice that there's no options associated with them that pop up. So I think that 550 is pushing this a little high, and we can call my max memory overclock 500. So we'll go ahead and exit this, put this back down to plus 500, and apply. At this point, we can start dialing in the GPU clock speed overclock. So let's go ahead and start with 50 megahertz and see where that takes us. Once again, we go ahead and start up Heaven. Here we are. We've got the memory overclock at 500 megahertz still, and the video overclock has been brought up to 200 megahertz, and I'm noticing some glitches here. As you can see, Heaven has just frozen up. Every once in a while it'll do that. It hasn't had a hard crash yet, but I mean, the stuttering and the freezing is telling me that this is not quite stable for Heaven. This is the kind of behavior you might notice. Now again, you might see artifacting, you might see hard crashes to the desktop. So we've got one right here. All right, so 20 has made it past the point of that crash with no problems, seemingly. It's pretty smooth, no stuttering, no crashing, definitely. So let's see if we can kick it up to 190. So take it back another 10. Apply that, make sure it's affecting both of the GPUs, and run. It's not exact, but you'll notice I have been taking it up 50. Once I saw a problem, I took it down 20. That caused no problem, so I'm taking it back up 10. Now, we did just see a little stutter, but maybe that was just a consequence of the program having just loaded up. So let's go ahead and leave this running a couple minutes and see if we run into any issues. All right, so we just saw some glitching at 190 megahertz. So let's take it down to 185 and see if that's going to be the magic number here. Remember, 180 was working totally fine, albeit just for about a minute or two, and 190 had a hard crash to the desktop. So maybe 185 is where we need to be. Again, leave it running for a couple minutes, see what that does for us. Okay, so we've been going for a couple minutes here and not seeing any crashes. That tells me that 185 on the GPU clock and 500 on the memory clock is our dialed in overclock. At this point, we'll want to start the Heaven benchmark once again and see what kind of score that gets us. All right, so our benchmark is done, and we have seen a pretty huge increase in performance to the tune of 20 FPS on average. Granted, our minimum FPS did go down a little bit, which is something that we ought to explore, and I'm sure our temperatures and average fan speed definitely went up. But that said, I'm encouraged by this performance, and the only thing left to do now is validate it by looking at some more intensive benchmarks and some benchmarks that run longer. So in order to make sure that the overclocks that we've dialed in with Heaven are actually stable, we'll want to run some kind of secondary benchmark, be that a program like 3D Mark, which is an actual benchmarking software suite, or just play a bunch of games on it and get that GPU cranking at the highest temperatures and at the highest clock speeds to make sure that things are stable and running smoothly. So for now, I will use 3D Mark because I find that it tends to be a little more intense, it runs a little longer, and I think it'll give us a good second indication. And if things crash with 3D Mark, then we know that it's got to be dialed down a little bit, and Heaven was not pushing this thing as high as it'll go. So TimeSpy is the DirectX 12 benchmark that 3D Mark comes with. There's also Firestrike Extreme, which is DirectX 11. Firestrike has a couple other variants too, like Ultra, which is for 4K, Firestrike Prime, I guess we'll call it, which is the more baseline one. But let's go ahead and try TimeSpy and see what that gives us. Well, with TimeSpy complete, we've got our score for the benchmark here, and this is pretty ludicrous. It is an enormous score. Certainly higher than any of my records before, although I've never pushed the memory clock quite so high, and frankly higher than I expected that this would be stable. I'm sure that this is in the 99th percentile or what have you of users. Looks like, yeah, I mean, certainly it is. But more than that, I think that this has shown me that you really can push the memory much higher than I expected. That's really all there is to it. At this point, you may want to run another benchmark that runs for even longer to make sure that this result can withstand hours and hours of gaming, or you can just start hours and hours of gaming. That's definitely what I would recommend. So just go into your profile here, right-click on one of the numbers to make sure that it is saved. And that way, when it starts up, you can click on Start Up there. This is the profile that will be loaded. You never really have to look at this again unless you want to see if you can push them even further. So I think that you guys can actually get even higher on the GPU clock on some other Maxwell cards, or maybe even on the Titan X. I'm really happy with the memory clock speed. I think that it helped us achieve this TimeSpy result that I'll definitely be bragging about to my friends and be bragging about on this channel well into the future. So there you have it. That's really all there is to overclocking these GPUs. Now, of course, this is how you do it with air cooling. In the next video, we are going to put these babies underwater in Nostromo and see what kind of numbers we're getting with that improved cooling performance. At the very least, it should be a lot quieter. Until then, this has been Eugene Tries.